Hi everyone, welcome to the System Thinking in Engineering Mechanics. Today we will talk about the cost product or how to find the moment in two-dimensional system. So the moment of force, or actually it should be the scalar formulations. In case of two-dimensional, the magnitude of the moment is equal to force multiplied with the distance d. So if the d is the perpendicular distance from the considered point that you want to find out the moment to the line of action of the force. So in two-dimensional system, the direction of moment can be the clockwise or the counterclockwise, depend on the intensity of the rotation. For example, so you have the considered point at O here, and then you have some objects that may give you A and B in terms of the coordinate. The direction D will be this term, or the shortest direction that make 90 degrees with the line of the force, which is this one. So we can use the moment directly if you have already known the value of the d. But in some time, if you didn't have the direct d or the direct distance from considered point and add 90 degrees to the line of force, you may use the concept of matrix, which is the cost product here. Because cost product said that if you have two vectors and cost together is equal to the magnitude of that two vectors, and then size the angles of that two vectors. So you can use it as the matrix as well. Let's see these examples. The example from the Hibbeler, number 48. Determine the resultant moment produced by the force about the point O. So we have two force here, and then you have to find out the moment at point O. So actually, if you use the concept of moment equal to force multiplied with the distance that's perpendicular with the line of force, you have to find out the line of force like this, and then to make sure that you got some d here. But sometimes it's quite difficult to find out the d. So in this question, we will use the concept of matrix. Let's see the first one here. Force number 1 can be defined as 500 4/5 of I, and then plus 500 3/5 of J, and this is our coordinate x and y. Or is this 400I plus 300J? This is force 1. The distance R here from O to A is 0.25 in J's, in positive J's, and then 0.425, which comes from 0.125 plus 0.3. in I. So I will rearrange these terms. To reduce some confuse here. For the moment of first vectors, you can use the concept of cross product as R cos F. Don't forget that you have to put the distance vector first. So you can write down it as 0.325 I plus 0.25 J, and then cos with 400 I plus 300 J. And because it is cos, if you cos between I and I, it will become zeros, and also J and J, it will become zeros. So you will have 0.325 multiplied with 300, and then I cos J plus 0.25 multiplied with 400 J cos I. And if you consider the concept of cos cycles here, I cos J will be equal to K. So this term will be K, and this term will be minus K because it's switched together. So the first term is equal to 127.5. For this term is 100. The result is 27.5 K because this term is the minus K. So let's move to the second force here. The second force is 600 cos 60 I minus 600 sin 60 J, or is equal to 300 I minus 519.62 J. Is acting on the same point at A, so you can still use the ROA as the distance between O. Consider points O and the point of force A. But for this one, I will show you how to use it in terms of matrix. So you can write out it as M equal to R cos F, and I will write out it in terms of matrix. Start with the R, vector R, and then vector F here, and you use the concept of depth. So if you multiply it double, it is the plus sign, right? But because of this, they have a minus sign on the force, so it will become minus 220.8 K. And then the upward 300 multiplied with 0.25, which equal to 75, but you have to put the sign minus here of k. So these together, the moment of force number 2 will be equal to minus 295.8 k. You can sum all of these together to find out the total moment or the resultant moment of this question. See you next video.